This is a video about how to conduct a goodness of fit test in SPSS. The chi-square goodness of fit test compares an observed distribution with what you expected. So for this example, we're going to see if our socioeconomic status distribution, which has three levels, low, medium, high, if that matches up with what we expected. So for that, we're going to analyze non-parametric tests, legacy dialogues, chi-square. This is where we go and we click all categories equal. Usually that will be highlighted like this. This is how it starts. And we choose socioeconomic status as our variable and we hit OK. Now, assuming that all categories are equal, we expect the same amount. So we expect a third of the population in each of these three categories. If you have four categories, it will be a fourth of the sample in each category, right? So here it is 55.7, it's a third. We expected 55.7 for the low status. We observed 62, so we have 63 more than we expected in low status. Medium status, we observed 48, we expected 55, so we have 7.7 less than what we expected. And then for high status with 57, we have 1.3 more than what we expected. Now we would calculate as chi-square based on these differences here. The chi-square would result in 1.808 with a degree of freedom of 2, right? N minus 1, 3 minus 1 is 2. And the probability to get such a result, such a chi-square 1.8 is 0.405. So this probability is way higher than the 0.05 that we look for, and we thus will conclude that this is a not significant result. So the observed distribution is not significantly different from what we expected. Now, let me show you how you would do it if you actually expected different frequencies for each category. You'd go back into legacy dialogues, back into chi-square, and now instead of saying all categories are equal, you could actually start entering your own categories. So let's just give an example. For the first category, for the lowest, we say we expect 1/10 of the people to be in there. So if 1 is 100, 10% will be 0.1. So we add that. Then we say middle class. Well, we expect about 0.7. 70% people are in the middle class. Let's just assume. We add that. And then we add for the highest status, we say 0.2, about 20%. We add that. We hit OK. And now you notice how these distributions change, these expected values, right? We still observe the same frequencies, right? 62, 48, 57, that's still the same. And now what we expected though is we said 10% will be low status. 10% of 167 is 16.7. Notice here we have a difference of 45. 62 more than what we expected. And right, it was really unrealistic that we only have 10% in the low status, but that's just to show an example. Then the medium status, we expected 70% to be medium, right? Again, a non-realistic assumption, but if we had that assumption, we would expect 116.9 people in that medium status. We only observed 48, so we see 68 more than what we expected. 68 less than what we expected. And then the high status, 50, we observed 57. We only expected 33, so we had 23.6 more than what we expected. If we calculate the chi-square based on these differences, we end up with a huge chi-square, 180. Again, same degrees of freedom. And now this 180 is highly significant. So we would conclude here that what we observed and what we expected, there's a significant difference between these two.